All right, so I think second period and third period finished all the way to the end of this page, but first period did not finish. Okay, so what we're going to do is we are going to start on example C. Keep in mind that third period and second period already finished this. C says, then draw a graph of the curve and the tangent line in the same square viewing window. Your tangent line is right here. So what I will start with is going to start with the y-intercept at -1, and your slope is -2. So up 2, left 1, up 2, left 1, up 2, left 1. Oops. And you are going to do just enough points to where you will have a straight line. Okay. So that's my tangent line. Oops, why did I erase that? I meant to make dots. Okay. So this is your tangent line right here. Try to make it as straight as you can. So this is y equals -2x minus 1. You also have a curve, which is, let's pinch that in really quickly. Y equals x squared minus 4x. So y equals x squared minus 4x. Now, in class, we use points. Keep in mind, I can also find the vertex. Okay, this is one of the many ways to graph a parabola. The vertex is what? I can find x by -b all over 2a. Okay, your b value is -4, so negative of the negative is now 4. 2 times your a value is 1, so currently you have an x value of 2. So that's your x value for the vertex. To get the y value for the vertex, you can plug that in. Again, this is just a different way of getting the vertex. So when x squared is plugged in, I'm going to have 4 minus 4 times 2. So that will give me a -4. So your vertex is 2, -4. That's just one of the many ways to graph. So 2, -4, 2, 4. So it's right there. It shouldn't be touching your tangent line if you graphed that slightly better than I did. Okay. Then because I have the vertex, I can pick 2 additional points, one on the left and one on the right. So I'm going to pick x equals to 0, because that's easy for me. X equals 0, y is 0, so that's one more point that I can use. Parabolas are symmetrical, so what's happening is I'm going to go to the right and get that. So if you notice, your tangent line and this curve should only be touching at only one location. Okay, it should, if I have a nice graph, guys, it should only be touching this point. Okay, 1, -3. My graph is a little bit off, and that's the problem of graphing by hand. Okay. Should be touching 1, -3. Right here is 1, -3. Okay, so that's one way to graph out a parabola. You can always make a table. Okay. So defining the slope of a curve at a point is, we're going to use the limits as h approaches 0. Remember, h is the distance from that given point, okay, over x of f of a plus h minus f of a, all over, okay? All over is usually x2 minus x1, but what's happening is that x2 minus x1, those values are always going to cancel, so your denominator will always just going to be h, okay, where a comma f of a, okay, is the given point. Now sometimes the given point, this is another same formula, just sometimes they give you x comma f of x, okay, is the given point. So if that's the case, you will also get the same formula, except instead of a, you will use x plus h minus f of x all over h. So it doesn't matter how they give you the point, the formula will always be the same. Okay, this is example 3, which is going to be new for all of us. Okay, find the slope of the curve f of x equals absolute value x minus 2 at the point x equals to 1. Again, they give you 1 point, okay, and they want you to find the slope of this curve at this point. Well, I'm going to need a y value. Okay, so f of 1 is absolute value 1 minus 2, which is going to be absolute value of -1, which is really 1. So the given point the given point is 1, 1. Okay. Then find the slope of the curve at a given point. Formula is, I'm going to use the formula that we just wrote down, the limit as h approaches 0. Remember, h is the distance from that given point of f of, you can use a or x, that's not important, okay? Since I'm using x, I'm going to plug in x. Well, here we go. Let's plug it in. We know what f of 1 is, okay? F of 1 is 1. We found it ourselves, okay? So what do we do from here? Limit as h approaches 0. I'm going to plug in now x plus h for my function, okay? X plus h for this function right here, erase. X plus h every time I see an x. Okay, so absolute value, oops, I meant to get a pen. Absolute value, this has 1x, so now that x gets an x plus h minus 2, okay, that's an absolute value. F of x, which is f of 1, because x is 1, will always be the same, okay? F of x, this is the part where some of you might get really confused, is this right here. F of 1, which is the same thing of f of x, which will never ever change. So that happens to be 1 in this problem. All over h. Okay. Well, x is 1 in this problem. So now that gets a 1. Okay. I'm writing everything down so that way you're not confused. X is 1. So now I have 1 plus h minus 2. Stay in the absolute value still. We'll work that out slowly. Don't worry. I just have to write everything out first. Okay, so limits as h approaches 0. So 1 minus 2 is now, what's that? Negative 1. So negative 1 plus h. Okay, minus 1 outside, all over h. Okay, well, you can write negative 1 plus h is the same thing as h minus 1, right? No difference there, just kind of rearranging that a little bit. Okay, so here's the part where it's going to be slightly unique because of an absolute value. This is where we are. Now you have an absolute value of h minus 1. As h approaches 0, okay, I want to know what's going on. Okay, so let's kind of spell this out. Since h approaches 0, okay, since h approaches 0, y equals, okay, so this is a piece that I think we're going to be very confused if we don't pay attention. An absolute value, okay, of h minus 1 has 2 different places, okay. One of it's going to be positive and one is going to be negative, okay. Let me just kind of graph this out so you have a really good visual of this. Here's h minus 1. Are you okay with that so far? I'm going to attempt to graph this out for you. Okay, so here's h, which is your input. Y is this function. I'm going to say, hey, I'm going to h minus 1, meaning that here's where it is, right? I'm going to go over here. It's going to be a v. Okay, I'm going to make a table if you didn't know how I get that. So when x is 0, 0 minus 1 is negative 1. Absolute value of negative 1 is positive 1, so that's why it's above. When x is 1, 1 minus 1 is 0, so that's how we got that piece. When x is 2, 2 minus 1 is 1. Absolute value of 1 is 1, so that's why this is this piece. So when h is approaching 0, okay, so now this is the part. When h is approaching 0, this is the piece that I want. Can you see this right here? So this is the piece that I want because this is where h is 0. So there's the limit, okay? The limit is that negative slope right there. So when I'm using this, this brings me back to my equation right here, okay? Limit as h approaches 0. When you have an absolute value, there are always 2 sides. One's a positive slope and one's a negative slope, okay? In this case, h approaches 0 happened to be the negative slope, which is right there. So I have to use the negative, okay, h minus 1, and then drop everything else down the same way. I will distribute that negative sign in the front, and again, I'm just going to write everything down. So it's a minus h plus 1 minus 1 all over h. Okay, so these are now canceling. I'm left with negative h over h. I can reduce that to now a negative 1. So this, y'all, is the slope. Okay, so what's difficult about this is because of that absolute value. The absolute value will always give you two sides. One of it is positive, one of it is negative, and you need to know when to use what. Okay, so there you go. And I would totally, you can always listen to this again on YouTube. Okay, so that's how we find a slope at a given point, 1 point. We're now going to try example 4. Determine whether the curve of this piecewise f of x equals to negative x, x is restricted less than 0, or x squared minus x, x is restricted greater than or equal to 0. Has a tangent at this point, x equals 0. If it does, give its slope. If not, explain why not. Okay, so what does it mean to have a tangent? Okay, what does it mean to have a tangent at a point? Okay, to have a tangent, okay, so let's spell this out. If it has a tangent, then it must have a slope, okay, at that point. Because if you have a tangent, that means you have a tangent line. To have a line, you have to have a slope. So what we're going to try to do is to find a slope at a point. Okay? So here's the formula. Formula for a slope at a point. Limits as x, oops, not x, h approaches 0. H approaches 0 of x plus h minus f of x all over h. Okay, well, our problem, x is 0. Okay, so what is f of x, which is in essence f of 0? Okay, so which one has a 0? This one has 0, so I'm going to use that one. So 0 square minus 0, which is 0. So guys, f of x, which is the same as f of 0, which is 0. This right here will always be the same. That would never change, okay? Now, let's plug in. Okay. Now, but before we go and to see if there's a slope, okay? To find out whether a slope exists or not, we need to find the left and right hand limits to make sure they're the same, because we're not sure right now. So, left hand limits, and they have to be the same. Okay, left hand limits. Limits as h approaches 0 from the left of f of x, right? X is in this problem 0, so I'm going to write in 0 right away. Plus h minus f of 0 all over h. Okay, well, this is limits as h approaches 0 from the left. F of 0 plus h is now just f of h, okay? Minus f of 0, it's always the same, which is 0, all over h. What on earth is f of h, right? Let's go find it. F of h, that means I'm going to substitute in h for every time I see an x. Well, which piece though? You got two pieces, right? Here's piece 1, here's piece 2. Since you have two pieces and you're approaching from the left, then I had to use this one because this is the one that x has left side. So when I plug that in, it's now limits as h approaches 0 from the left. It's now negative h, okay, minus 0, it's just in essence nothing, over h. I can reduce that down to negative 1, okay. So now I have left-hand limit of this function is -1 at x equals to 0. Let's do the right side to see if it's the same. Right hand limit. Limit as h approaches 0, okay, from the right, same thing. I'm going to plug all of that in, same formula as you can see, okay. Again, this right here is an algebraic value. It should not change from your algebraic work, okay. Now, 0 plus h, it's also just like earlier, it's just going to be f of h, okay, minus f of 0, 0, all over h. The question is, this f of h right here, because I'm coming from the right, I have to pick the correct piece, because there are two pieces, okay? So let me erase some things here. Because I'm coming from the right, this is the piece that I need to use, x squared minus x. So when I substitute that in, limit as x approaches 0 from the right, every time you see an x in this piece, now it gets an h squared minus h. Minus 0, it's obviously nothing. So I can take out something from the top, factor it out. Okay, so if I factor out the top, I will now have an h times h minus 1 all over h. Okay. This will cancel. So as you can see, I have a limit as h approaches 0 from the right of h minus 1 left. By substitution, my right hand slope is now -1. Since left and right slope are identical, we can say that the slope does exist, okay? The slope, therefore, m equals -1 at x equals to 0. Okay, so I have a slope at x equals to 0. Because I have a slope, we need to go back and answer our question. Determine whether the curve has a tangent. Yes, it does, okay? If it does, give a slope. We already have a slope. So, yes, there is a tangent. At x equals 0. And it said if it does, give me the slope. Slope is -1. Okay, so again, just to kind of recap, for you to have a tangent, there has to exist a slope, okay? So we found left and right limits, and they are exactly the same. That means the slope is -1. And I'm going to pause that for a second so you can get the writing done. Okay. Normal line is actually quite easy. You have done this before. Normal line is a line perpendicular to the tangent, okay, at that point. So normal line, orthogonal, all of that is still perpendicular. All right, here we go. For the curve y equals x squared minus 3x minus 1 at a point x equals to 0, find a, the slope of a curve. Okay, so the slope of a curve, again, I would need the formula at a point. So limit as h approaches 0 of f of x plus h minus f of x all over h. I don't know what f of x is. Okay, so let's find f of x. F of x, x is 0, so f of 0 is, let's plug it in. 0 squared is 0, minus 3, so 0 squared is 0, minus 3 times 0, minus 1, so it's really 1. Okay, so 1 is f of 0, which is really f of x. And the reason I'm writing this out again is because these will always be the algebraic value. Well, so limit as h approaches 0, okay, x is 0, is that okay? So I guess I'll write this out this time. So minus f of x, which is f of 0, which is 1, all over h, okay? 0 plus h is obviously just h, so h approaches 0. I can now put in h for every time there's an x value. So let's do it. Okay. That is now h squared. Okay. This is now minus 3h. Drop the 1 down. Minus, okay, so minus your f of x is 1 all over is it 1 or negative 1? I think it's negative 1. My bad, because this is 0, this is 0. That's negative 1. Sorry. This is a minus a negative 1. There you go. And all over h. Okay. 2 negatives will make it a positive. Okay, so 2 negative to make it a positive. So now limits as h approaches 0 of h to the second minus 3h. These two will cancel one another out all over h. And as you can see, that you can factor it out and then cancel, or you can see that they're going to cancel, which I'm just going to factor just in case some of you can't see it. Okay, I'm going to factor out that h. It's now h minus 3 all over h. So this is now going to cancel. So now by substitution, this is going to turn out to be negative 3. So guys, your slope of the tangent is negative 3. Write an equation of the tangent. Y minus y1 equals m times x minus x1. Your point, y minus a negative 1, that comes from here, right here, equals, your slope is negative 3, x minus, this point is 0, so minus 0. So y plus 1 equals negative 3x. Move the 1 over. So your final equation is going to be y equals negative 3x minus 1. That's the tangent. Part C is going to ask you to find the normal. Well, just like in Algebra 1, the normal is going to be opposite and reciprocal. So opposite of negative 3 is now positive 3. Reciprocal is now 1/3. And you're going to do the same thing. Y minus y1 equals m times x minus x1. y1 is still the same. I'm using this one right here, negative 1. Okay, the slope is now opposite and reciprocal. X minus 0. As you can see, it's x plus 1 equals 1/3 x. Move the 1 over. Y equals 1/3 x minus 1. And that is the line that will be normal to the tangent, aka perpendicular. D is just asking you to draw all of it out. Okay, no big deal. So I'm going to draw out the normal line in black. How about that? So we'll start at negative 1, which is the y-intercept. The slope is positive 1 over 3, positive 1 over 3. Or I can go this route as well. All right, so this right here is your normal line. Y equals 1/3 x minus 1. I will do your tangent line in orange, okay? The slope is, the y-intercept is still negative 1. Your slope is negative 3. So down 3, right 1. Oh, up 3, left 1. Up 3, left 1. So this is your tangent line. Okay, it looks like it's intersecting at 90 degrees. So y equals negative 3x minus 1. Then I will attempt to graph your curve. Where's your curve at? Let me find the curve is y equals x squared minus 3x minus 1. I'm going to find the vertex. That way it's easier. So vertex, okay, x equals negative b all over 2a. Negative b is now 3, okay? 2 times 1, so that's going to be 1.5, or 3 over 2 is fine. So your x-coordinate of the vertex is 1.5, or 3 over 2. Let's plug that back in to get y. Y equals 3 over 2 squared minus 3 times 3 over 2 minus 1, okay? Let's work out the basic math. So let's see. 3 over 2 squared is going to be 9/4, okay? 9/4 minus 3 times 3/2. That's going to be, what's that? 9/2. Okay, so 9/4 minus 9/2 minus 1. So all of that's going to come out to be negative 13 over 4 because you have to find common denominator. So that's your y coordinate. Okay, so that's your vertex. Let's plot that in. So let's use blue. Okay, so the vertex is 1.5. Negative 13 over 4, that's going to be what? Negative 3 1/4. So 1 1/2, go down negative 3 1/4, somewhere right there. Okay. No big deal if you can't find the exact value. Then I'm just going to go when x is 0. When x is 0, okay, y is going to be negative 1. Awesome. Whoa, look at that. Okay. Then it's symmetrical. So when x is 3, it's also the same y value. Did I say 1 or negative 1? I meant to say negative 1. There you go. Okay, so that's your curve. The tangent is in orange. Remember that. So it only intersected one time. So y equals x squared minus 3x minus 1. That's all of the stuff together in one screen. Okay. All right. And I think this is where I'm going to stop for this video now. And feel free to listen to it again on YouTube.